Hello everyone, and welcome to this video about ratios. Now, ratios are tricky little things. They work sometimes just like fractions, sometimes not really like fractions, but we're going to explore a few things today. Okay, so ratios tend to represent quantities that make up other quantities, I guess you could say. So, for example, something could have 3 parts water and 4 parts flour. It would be a ratio of 3 to 4. Okay, so we could actually set that up as a fraction as 3 over 4 to work with it a little bit easier, but it's really 3 to 4. Okay, and we like to keep things fairly equivalent. We can use equivalent ratios just the way we can use equivalent fractions. And we can find those bits and pieces of information using factors, common factors, highest common factors, and the like. Now, a couple of things to know about ratios. Alright, so we're going to write these down. Or I'm going to write these down. So a ratio, a ratio is used to compare. Okay, we're doing comparisons. This is all about saying what is one thing in relation to another. And this is in terms of quantities and amounts and things like that. Now these have to be of the same unit. Okay. These need to be in the same unit. If you're using dollars and then you're using cents, the ratio isn't going to work. You need to be dollars to dollars or cents to cents. Okay? Same in other types of different measurements, so grams to grams, not grams to kilograms. And you don't want to go centimeters to meters, you definitely want to be centimeters to centimeters or meters to meters. Okay? And they should be in order. So if we were to say 3 parts water, 4 parts flour, like we said before, but we put it around the wrong way and we had the water being made second, it would be 4 parts water instead of 3 parts, and that wouldn't work. Okay, so we need to make sure that we are using the definite order and we're making sure our order is correct. The other note that I'd like to make is all about equivalent ratios. Equivalent ratios. Okay, and these are obtained Alright, so we can obtain these equivalent ratios by either multiplying or dividing. Okay, so we can go either way. We can multiply or we can divide, but it needs to be by the same number. Okay, if it's not the same number, we're not going to have an equivalent ratio anymore. Things aren't going to match up the way they're supposed to. Okay, so these are ratios. This is very, very simple on the ratios. And what we're going to do now is we are going to do some examples. So these examples come from the Cambridge Mathematics Standard 1 Mathematics textbook from New South Wales. Okay. The first one, we have 20 to 4. 20 parts to 4 parts. And all we really need to do here is find a highest common factor. So I'll make that note in a different colour. Find the highest common factor. And then we're going to create a division. So our highest common factor for this one is obviously going to be 4. 4 being the largest number that goes into both. Okay. And then we're going to create that sum. So we're going to go 20 into 4, or to 4, okay, is going to equal 20 divided by 4 to 4 divided by 4. Okay, and that's going to get us where we need to be of 5 to 1. Now, for our second example, we have the ratio of 3 to a half. Now, one of the things to note about ratios is you cannot have fractions and decimals for a proper ratio, or for its simplest form of a ratio. The simplest form of a ratio is always whole numbers. So what we need to do here is we need to change that fraction to a whole number, but we need to do things in a way that's going to keep everything equivalent. So let's make a quick note. So when simplifying ratios, we must get whole numbers. Okay, so no fractions, no decimals in our final answer here. So that's why with the 3 to a half, we're going to actually multiply instead of divide. So in the first example, we divided. In this one, we're going to multiply. And we're going to multiply by a number that's going to get us to our whole. Okay, so let's go back to my blue pen. We have 3 to a half. Now the easiest thing to do is look at the denominator of that fraction. The denominator of that fraction is 2. So what I'm going to do is I'm going to multiply by 2, because that's going to turn that half into a whole. Okay, so here we go. We're going to go 3 times 2 to a half times 2. And that's going to get me to a whole, and it's going to give me my simplest form ratio. So it's going to be 6 to 1. Okay, so if I had a third, we'd multiply by 3. If I had a fourth or a quarter, I'd multiply by 4. We want to multiply by something that's going to get me to a whole, and the first whole number obviously is 1. So that's what you want to be getting to. Let's look at our final example now. Our final example is that decimal example, very similar to fractions in that we need to do something to make them whole numbers. And again, easiest way to do this is to multiply. Okay, so one more little note. Alright, so we're using decimals or fractions in the ratio. Multiply to get the simplest form. Okay, so we're going to multiply for this problem. Easiest thing to do is to look at the decimal places. So for this one, we have 1 decimal place here and 1 decimal place there. So we only need to move 1 decimal place. To do that, we multiply by 10. So I have 1.5 to 3.5. I'll just put that decimal point in the right spot. So 1.5 to 3.5. And if I multiply by 10, I get rid of that decimal point because it changes the place value, but doesn't change the actual value of the ratio. The ratio is still an equivalent ratio. So there we have it. We have 1.5 times 10 and 3.5 times 10, which gives us 15 to 35. Now, you may notice this isn't actually the simplest form yet. We have 15 and 35. Both those numbers have factors. Okay, they're not prime numbers. If they were prime numbers, or if one of them was a prime number, we'd have our simplest form. So, for example, in the first one, we have 5 to 1. They're both prime numbers. Simplest form. In the second one, we have 6 to 1. 1 obviously is not a composite number. So that's simplest form. And now we need to do the same for this one. So, what I'm going to do is I'm going to find that highest common factor again. And for this particular problem, that highest common factor is 5. So when we do our division, we're going to divide by 5. Okay, and as you can see there, I've done it slightly different to how I did the first problem. So the first problem I used the division symbol. This time I've done it as a fraction because you'll notice that there is a bit of a link there and it's easier to work in those fractions at times. For this one now, we're going to finish the simplification, and 15 divided by 5 is 3. 35 divided by 5 is 7. So there is our simplified ratio, 3 to 7. That is the simplest form of the ratio for this particular question. That's all we have for ratios at this point. Hopefully this has been an informative video for you on ratios. Good luck with all your ratio problems.